Lots of technology.
Hey folks, we are live finally. Let's just do a quick sound check. Claire, can you let us know in the comments if we're all good sound wise?
Can you hear us?
Test from Adam.
There's a delay.
Let's see. They'll let us know in a second in the chat, and then we'll jump on in. Boom.
All right.
Yeah. All righty. We're good.
Awesome.
We're good. So thank you guys for bearing with us. One of our classic little crowdcast tech issues, but we're over it, which is great. So big welcome to everyone to Sustaining Peak Performance During a Pandemic. This week we've got Dr. Adam Gazzaley, who is, and Adam, am I pronouncing that right? Just to double check.
Gazzaley. Yep.
I practiced a couple of times, but I want to make sure.
It was impressive. That's good.
So we've got Dr. Adam Gazzaley here with us today, who is a go-to neuroscientist for us at the Flow Research Collective. Adam has an MD and a PhD in neuroscience and is a professor at UCSF. And Adam is the executive director of Neuroscape, which we're excited to learn more about today, which is a translational neuroscience center working in technology creation and scientific research. And he is known for designing and developing brain assessment and optimization tools and using cutting-edge technologies in rigorous research studies. His work has a wide-ranging impact across a number of different fields: education, medicine, VR, the list goes on and on. And he's also an artist who's done a bunch of really interesting projects, including lots of stunning photography. One of his artistic collaborations was with drummer Mickey Hart of the Grateful Dead on inventing new ways of showing the beauty and power of rhythm. So huge welcome, Adam. We're stoked to have you join us and stoked to dive in. I know Stephen's got a few quick words to mention about how you guys connected in the first place and where we want to go today.
Great. Thanks for having me here.
Hey, everybody. Welcome. Thanks again for joining us. I think this is week 7, maybe week 8. I've lost track. I'm incredibly excited to have Adam with us today. As Rian mentioned, he is one of our go-to guys for neuroscience. I think he's I think he's a rock star in the field, and he's doing some of the coolest work on attention and distraction of anybody out there. And he's probably been a little farther under the hood of some of the major flow triggers than almost anybody. So we're going to get into all that, and I'm really excited to begin. Rian, why don't you kick us off?
Totally. So Adam, let's just dive straight in. So for years now, you've been a leading expert on the distracted mind and the idea of distraction and how technology can cause interference. So with the world making a shift toward online everything during the pandemic, could you tell us a little bit about both the issues and the opportunities you see for neurological well-being, given the increased use of technology since this whole pandemic has kicked off?
Yeah, it's a great question. First of all, I just want to thank you for having me on your show and to talk to this audience. I see so many people. It's great to be able to connect while I'm locked in my home, which you see behind me. Just from a high level, I view this crisis that we're in as having sort of 3 waves. The first wave was obviously the viral respiratory crisis. The second, which has followed closely behind it, is the economic one. And the third is really one of mental health. And I'm using that term very broadly here to just encapsulate all of the health of our minds, whether you're suffering from a clinical condition or you were formerly very healthy. And I find the challenge of wrapping my head around how we deal with this situation to be incredibly complex and obviously dynamic and changing all the time. And no one really has the answers. We've never been in a situation like this ever before. I would say that the technology part of it is particularly fascinating because as I, have written and talked about, including in my book, The Distracted Mind, technology has placed an incredible challenge on our brains, on how we process information, on how we relate to each other and ourselves. And now we use technology more than ever, especially children. Like I talked to friends of mine who have kids, and they've like abandoned all hope of any restraints upon their use of screens. And they're like, well, what does this mean? Because before this, we were trying to, tailor it back, or at least give some moderation. And so, I would also say that with any challenge, there's opportunity, and all swords slice both ways. So in addition to being able to understand what the challenges are from technology, I find it really fascinating to think about what is the opportunity to use technology to help us manage not just like the communication like we're doing now, which is obviously very important, but really as a tool to help us enhance our minds and really thrive, if not survive. That's the goal. How do we get through this? Not just as good as we were, but somewhere better.
Love that. That makes total sense. So I'm curious, what's the most common question that you get asked about distraction and about the distracted mind?
You mean now or in general?
In general, pre-COVID.
Pre-COVID. The question that I'm asked the most, I think people are, trying to wrap their heads around how the messaging had been seemingly for so long that we should just be multitasking like crazy. We have all these opportunities, all these devices, all these browser windows, and our phones are meant to switch between. And so we're given one message, and have been for a long time, that this is the way we're maximally productive. And then an alternative message has been coming out, one of which that I've been generating a lot of research for in our center at UCSF, as well as in books and talks that I give, that our brains just don't really handle this type of interaction with information very well, to use that very globally, with or without technology. So I think the most common question I'm asked is how do people reconcile what we were thinking was the route to be productive and to use technology in an optimal way, and what neuroscience is telling us is not the case. So that's probably the most common thing.
Adam, can I want to jump in and ask you a question.
Yeah,
and it's sort of tied to this in a sense. I'm going to ask you, it's a two-part question. One, talk a little bit, just so people have a foundation of this, about how goals impact attention and how they serve as kind of a top-down attention mechanism. And the question I have for you is, how does long-term goals impact attention? And I'm really asking a question at like a thalamic gating kind of level. We can unpack the neuroscience along the way, but I'm really, it's been fascinating to me. You're one of the only people I know in the world who really works on the goal-directed system, first of all, and is even thinking about long-term goals and how they affect perception, thalamic gating, all that sort of stuff. I'm going to take us from multitasking into the deep end of the neuroscience in a minute. But I've got you. So, you're a captive audience. So I got to ask you.
No, I love it. And we've talked about this as well a bit. Let me just create a little bit of a landscape for us to talk about attention. Attention is one of those things, even some very famous psychologists have said, oh, attention, everyone knows what it is. We think it's obvious, and we use it across every field. But attention is super complicated. If we had a whole hour to talk about attention, we would definitely not get through it all. And so I'm not going to try to unpack it in all of its beautiful complexity and nuance, but I do want to just frame it from one perspective, given your question, this idea of bottom-up and top-down attention. And then we'll talk about short-term and long-term. So the most ancient aspect of attention, the one that we evolved for our survival, is called bottom-up attention. And that's how the environment itself demands your attention based upon the salience or novelty of the stimuli. So this is what allowed our ancient ancestors, even if you go back to single cell organisms before we had a nervous system, to survive, to basically avoid threats and toxins and seek out nutrients and eventually mates. And, and so we're, our other animals and us to some degree too, are constantly directing our attention based upon the environment itself. It demands our attention and it moves it around, and it's largely reflexive, and we retain a lot of those reflexes. So fortunately, because we still use them for survival. That's bottom up. Top down, we're as animals, as humans within our species, and as animals ourselves, that is where we're most advanced, is top-down attention. Top-down is where your attention is not driven by the stimuli themselves, they're driven by your goals. So you make decisions and you decide, I am going to direct my attention towards that or away from that. So that goal-directed attention or top-down attention is sort of, I would say, the pinnacle of human brain evolution. And it's what allows us to do everything that we've done, from society to language, music, technology, art. All of that demands top-down attention. But we're always in this conflict of bottom-up and top-down, right? So even now I'm struggling with it because I'm not like in the perfect setting to have this exchange. There was a horn outside, pull my attention away. I know my wife is upstairs on another call. I could sort of hear her a little bit bottom-up. And so this is how we navigate the world, whether we're aware of it or not, is balancing bottom-up and top-down. And they're always at an interface, and you're always struggling to assert your goals over the environment and vice versa. And that happens every moment, right? We constantly flow through this interaction between bottom up and top down. And that's happening in the very short term. And it influences everything. It influences our memory, our perception, our decision-making, our emotional regulation. All of it is being influenced by those two attentional forces. And just to like wrap up and not go off on too far on a tangent. So in terms of long-term planning, that's even more human than what other animals are capable of. And that takes even more top-down effort and control and attention. And it intersects with all those other things as well. But the real challenge of this research is understanding how those long-term goals mediate the attentional flow in the moment. And that's something that we're interested in, that we're looking at. So when you enter a situation, this is sort of the interface that I think between intention and attention. So attention are the resources, the top-down attention that lets you put your limited mental power where and when you want it. And the intentions are how you make the decision about where it is. And obviously, it's the intentions that are influenced by those long-term goals.
Adam, I think it'd be really helpful for people to distinguish between awareness and attention. Or how do you think about that?
So awareness, arousal, attention are different, right? They all intersect. Arousal is obviously just your general sense of whether you're drowsy or awake, but it intersects with your attention, and your attention, as I said, it's complicated. Attention includes focus and ignoring. And things that are usually in your top-down attention, they're in your awareness, but attention's complicated. So things that may be pulling your attention in a bottom-up way may be completely outside of your awareness, right? We call that like subconscious decisions that you make. So, they overlap. They're not like completely orthogonal, but they intersect all the time, those three concepts.
Adam, hold on. I gotta ask a question based on what you just said. Adam gets a little smirk every time I jump in.
I like it.
So bottom up attention, when we talk about arousal, you're essentially talking about an acetylcholine reaction. Top down, same thing. Is it also acetylcholine? If the minute you get excited or anxious or whatever, you've got other neurochemicals coming in. But I was just wondering if it's the same system, bottom up and top down.
Yeah, I would say so. We see the cholinergic system involved in both of those types of attentional processes. It's probably how it has a lot of its benefit in conditions like dementia, where we give cholinesterase inhibitors to boost acetylcholine levels. But it's a good question, and it's something that is an active area of research in parsing out its different roles and different types of attention.
Okay, Reed, I'm sorry I cut you off, please.
No, you're all good. You're all good. So, am I right, Adam, based on what you were saying previously, in thinking that there can be distractions that are outside of our awareness or outside of our conscious awareness, yet still distracting us, even though they don't feel like they are?
Undoubtedly. I mean, that is, it's a massive source of distraction, or bottom-up influences that could fall outside of our awareness. They could be both internal and external. That's yet another way of breaking down attention. You could direct your attention inward, like in a lot of meditation practices. You could put your attention externally. Just like your attention can be focused internally or externally, the interference in attention. So I think I like the concept of interference. Like it sits well with how we think about signal and noise, right? You're trying to get a signal in the radio and there's noise. That's the same thing with attention. Attention is you're trying to have a signal based upon, let's say, your goals, and there is interference and noise. That's what I think of largely as distraction, and then multitasking. And if you want, I could break down sort of the conceptual framework that we built to separate out distraction and multitasking. I think they're different types of interference, but both of those types of interference, distraction, which is completely irrelevant information you're trying to ignore, you want to ignore, and multitasking is when you make the decision to engage in more than one stream. Both of those types of interference can enter and cause interference both externally or internally, and they can occur both with and without awareness.
Can I ask a weird question here? When we talk about distraction, does it register? Does the anterior cingulate cortex register distraction as a kind of error correction? Does that make any sense?
Say it again. What you mean?
When we're distracted, I guess let me back that up. When we're distracted, where does the signal show up in the brain? When we say distraction interrupts attention, what are we actually talking about at a structural level?
It depends. It depends on the type of distraction and the type of activities that you're engaged in at the moment. So as we all know, and I bet a lot of your listeners appreciate this, but I'll pause on it for a moment because it's so important. Our brain doesn't work as a bunch of separated islands of processing. It works as a network. It's an interconnected dynamic system that is constantly shuttling information in all of its its great extent of processing. Now, when you are engaged in a certain activity, let's say it's a visual activity, there's lots of areas that are associated with what's going on, right? So you have your visual cortex and the occipital lobe, where you're processing that visual information. Obviously, it's coming in through the brainstem and passed through the thalamus. But then you have the prefrontal cortex, which is where your top-down control is largely thought to be mediated from, right? And we know this is the most evolved part of our brain. We see that there's a network, there are certainly structural connections between them, but functional connections between them. And then, of course, if there's memories involved, your hippocampus is part of this network, emotional salience, then you have your amygdala. And so you have this network of brain areas, and the network has to be engaged in order for you to process it in a meaningful, high fidelity manner. When we present someone with interference, we see a couple things. So if the interference is just a distraction, then what we find is that there is a loss of fidelity of the resolution of that information that's being maintained in the sensory cortex where it's being processed. So that's why I said it depends, right? So it's specific based upon whether it's auditory or visual information that you're processing at the time. And we could see that in a whole bunch of different signals. Interestingly enough, what we find in the setting of distraction is that you can often maintain that network, but it's presumably, from at least as far as we can tell from the measurements that we do, it's still activated, although probably not, and we can know this from the behavioral data, not processing as high at a higher fidelity level. If your interference, here's my wife, bottom-up stimulus. If your interference is multitasking, right? So if it is another task that you're engaged in, then what happens is that network basically breaks down and you form a new network. And then that new network lets you approach that task with, high fidelity. And then when you switch back, you basically break down that network and reactivate another network. We've seen this with both fMRI and some degree with EEG recording as well. And so those two types of interference, distraction and multitasking, a secondary task, seem to have a different signature upon which they break down performance. And so that's how we, at least when we're looking at this from a neuroscience perspective, how we make sense of why we can't seem to just completely filter out everything that's irrelevant based on our goals, and why we're not able to take our attention and apply it to more than one task at a time. Because what we do not see is that we parallel process those two networks simultaneously. And so that's a little bit of the neuroscience behind distraction multitasking impacts.
So Adam, so we've got kind of awareness, attention, arousal, interference, obviously, and they're all somewhat, interrelated and then also unrelated. Is there an analogy or a visual that you use when describing awareness versus attention versus arousal? And I've heard of that idea of, the lighthouse with the fog beam being awareness, and then a more specific, beam being attention. Do you use any kind of analogy to sort of tie a bow on that for folks?
I don't think I haven't really thought of an analogy that tie them all together. Obviously, the spotlight of attention is a classic visual analogy that we use to sort of help people understand how you can move the spotlight around and things are outside of its awareness. I don't really love the spotlight analogy, because what we've learned in our research is that it's not really like a spotlight, because what's happening is a spotlight implies like one directional influence, right? So like you're putting a light on something and everything else is denied light. That's not what we find in our research. What we find is that when you pay attention and focus on something, it's true, it's getting the lion's share of your processing, and you see tons of different neural indicators showing that that's true. But what we have found is that your processing of the irrelevant information is not just denied the focus, it's actually actively suppressed. And so I view both attending and ignoring as active processes. And we've actually shown in our research that they can be dissociated. Yeah. So one of our first papers showed that older adults are able to focus like 20-year-olds, but not ignore. And that's what creates all of their attentional problems.
Oh, wow. Adam, I want to follow up on that. So the finding, correct me if I'm wrong, but my understanding of it is that older adults, and it takes place in like the first 1/10 of a second, right? That they don't suppress information like younger people. So what changes? Is that a thalamic gating thing? Like what is going on there that degrades in older people?
Yeah. So we had a series of papers. I mean, it's been
a while.
It's been like 13, 14 years ago from some of those first papers. And what we showed was that it was actually started with a Nature Neuroscience paper where we showed that there was a selective suppression deficit in older adults. That was done with fMRI. Showed that if you use measures of focus, they were preserved. They looked like 20-year-olds. Where they were failing was the ignore side. And the degree that they failed, like if one older adult, healthy 60 to 80-year-olds, if one older adult failed to engage their suppression mechanisms, that directly related to their memory of the relevant information. So showing that it had like real meaningfulness to how you process information because it creates interference. We showed in another paper in PNAS that we followed up doing it with EEG, where we could look at the temporal details of this, right? The timing specifications, that this failure to suppress irrelevant information occurs very, very rapidly within hundreds of milliseconds. Now, so you may think that, wow, anything occurring so fast is happening, right basically from thalamus to, to visual cortex, and is not really subject to top-down processing. And that was actually a dominant view in the literature when we published this paper. But then what we showed here with a couple of different manipulations is that based upon your top-down goals, so clearly beyond the thalamus, prefrontal cortical areas, you're able to modulate activity in visual cortex within like 150 milliseconds. So really, really fast. So yes, we believe that it probably involves the, some gating of the transfer of information from like thalamic areas to visual cortex or whatever, sensory cortex we're talking about, but it is under top-down control. So it's very fast that you get to apply this. So our conclusion was that older adults are not able, it's not that they can't filter at all. They could suppress, but if you don't do it right at the beginning, like, 0 milliseconds on, if it hasn't started, then irrelevant information comes in and creates interference with the relevant signal. And then you get all those negative effects.
Let me ask you next, a follow-up, which is John Koinos, Mark B, and a number of other researchers who work on creativity find that one of the things that's consistent with creatives and the brains of creatives is they don't have repetition suppression, right? They don't as much. They perceive familiar stimuli as novel instead of as, oh, I've seen this a million times, right? Because that gives them more novelty, which is the foundation of pattern recognition, which leads to more creativity. So does this mean, because older adults don't, is it a different repetition suppression? It's the same kind of mechanism we're talking about here? Does this mean, I know there's a spike in creativity in people over 50. Is this why? And by retraining the brain to focus like that, is there a creative cost? Are these just weird ass questions?
No, it's a good question. Repetition suppression is different than this type of top-down suppression. And our brain does all sorts of suppression as part of perceptual processing. So it's a very complicated topic, and we probably don't have time to like tear through all of the different aspects of suppression. I mean, I love the whole idea of suppression. If you think about like bonsai, like creation, right? Like a lot of it is the pruning process, and even sculpting in general is like you have the clay and then you pull things away. It's very much like that with perceptual processing. A lot of the real power is what is removed from it, not just what is added in. In terms of suppression and creativity, I back in the day, I haven't studied this particular topic of aging and suppression recently, but back in the day, this was a constant area of questioning, because a lot of older adults were like, but the fact that I can't suppress is a good thing because I'm taking in more information and it stimulates my creativity. I had this whole like sort of not battle, but this whole discussion with another researcher, and I think it was in the New York Times, about how losing suppression ability might be good. I would say.
What do you mean? I'm not the first guy down this road?
Yeah,
damn it.
No, not the first. It's been a long time though, so I'm like trying to refresh my memory. So yes, I think that, sure, if you suppress everything so like well that you basically create a tunnel vision for yourself and you can't bring in new information, then sure, it could restrict a lot of creative processes. I think that makes sense. The reality is, though, if you can't suppress and you are just having a flood of new information all the time, I would argue that that is going to be interference in the goal-directed processes that are required to make your creativity actually productive.
It would sound
So
okay.
to do something with it. So maybe you're a brilliant artist because you're seeing all these things and these things are happening, but maybe no one is ever going to know about that because you're not able of putting it together and delivering it. So, somewhere in the middle is probably the sweet spot.
Right.
Got it.
Got loads of amazing points here. So ignoring is an active process. I want to reiterate that for people. Then you've got attending and ignoring, and the idea around suppression. When it comes to attempting to increase focus and reduce distraction, do you think about strategies through the lens of things that increase our ability to attend and decrease what we have to ignore? Is that the simple way to parse out different strategies or techniques?
Yeah, I mean, in the simplest way, if suppression is an active process and demands resources, one of the strategies is to just decrease the amount of distracting information around you, right? So that you could take more of your resources and apply it to focusing on what's relevant, which is, a very classic strategy of minimizing your workspace, of decreasing the number of browsers are open, trying to single task when you're doing something that really requires high level processing. So I would say that neuroscientific nugget is directly applicable to this idea of minimizing clutter, both external clutter and internal clutter in your mind.
Yeah, I think it was you who said that, just literally the option to check your phone is itself a distraction. In other words, because obviously it's playing on suppression in that respect. So no, that's exactly. Super interesting, super helpful and practical. And then just on the practical application note, what are the standard strategies, tools, tips that you recommend for folks to improve focus, reduce digital distraction, etc.?
Well, the first one we just talked about, clutter, and that's probably more important and challenging now, like just to make this COVID relevant, because like we're all in this situation, probably almost everyone on this this discussion is at home in a place that is probably not optimized for focus. It may be more optimized for interactions with your family, which seems appropriate, or relaxing, or dinner. You could see I'm struggling with trying to make my environment conducive as well. But since we've been home, I've been working on that to make my workspace able to you can't really see what I'm seeing, but to have a nice clean palette to be able to focus on. So that's really important. And then remember, I also said that the clutter could happen inside as well as outside. So another challenge, you're worried about this or that. All of those are internal sources of distraction, and they will be unrelentless, and they will impair your productivity and your performance just as much as external clutter. So that's one thing. And there's no simple answer, right? It just takes practice, new habit formations and management, and maybe principally being aware of it, being able to be introspective about the sources of interference in your life. And it might not just be productivity that it's interfering with. It could be your relationships, your connection with people you care about. It could be interference with your sleep, and tons of different ways that interference has negative consequences. The next thing I would say is learning. Again, it's a little bit metacognitive. It's learning yourself and understanding that fatigue is not just something that's related to our physical bodies. Like, we've wrapped our heads around that really well. Even like Olympic athletes and professional athletes of all kind know that if they are going to continue to engage in their training or their performance activities at a high level, they need to have rest. They need to restore from fatigue so that they can re-engage at that level and maximize their learning and growth. It's the same thing for your brain. We will fatigue, and we require restorative periods in order to re-engage. It's much less research for the brain than it is for physical body and muscle type of fatigue. And so I'd say, for people that are trying to learn how to focus better, one of the practices that I engage in is to take a healthy and open look at what you do to restore and when you restore. And do you put in scheduled breaks in order to allow yourself to recover? Or do you think that's a sign of weakness, as I think a lot of people used to do, including a lot of employers, and think that you just have to push through 8 hours of uninterrupted activity, which is likely impossible? And then the next question is, what is the break that you're taking? Is it going on social media where you just go down these iterative sinkholes and it gets more and more complicated in order for you to get out? I would say that the breaks, from my impression, that are ideal are a little physical fitness. So if you could do a little walking, some push-ups, something to stimulate yourself physically, being able to shut down the noise, whether it's like meditation that allows you to have a solitary focus. So I think that those are two really good activities. Probably one of the best is to being able to engage in nature. Now, that might not be easy depending where people are located, but sometimes I'll even look at something as simple as a screensaver of nature photography to be able to just allow the mind to free itself from the top-down goals. So the message here is that if you want to restore your top-down attention, one effective way of why nature is effective is to have a strong bottom-up influence that allows you to just take a journey.
Hey, Adam, you started echoing there. Is there another browser window that got open?
I hear that, but I thought it might have been coming from your side.
I can, maybe it was me. I can hear you
Let me try. Yeah. No, it's gone. Oh,
okay.
Let me ask. I want to ask you a quick question. It's a little related, a little different. You talked. I think it was a lecture you gave at UC Irvine a couple years ago. You mentioned that texting impacts reading retention, and you said you were going to follow up on it or were thinking about it. I wanted to know if you ever did follow up on it. The idea that because texting breaks up language and we don't use language normally when we go to read books, the fact that we're texting in weird ways is actually impacting our reading retention. Is that something you followed up on? Is that real?
Yeah.
Do we know that?
No, we haven't engaged in that study. I remember we were talking about that, but it's something we haven't really pursued. I hear the echo too, and I see your folks. When I
No, we can't hear you at all, brother.
Could you hear me now?
Oh yeah, the echo's gone.
It's gone. Oh yeah, I think it's gone. Okay.
I think we're good.
Let's try.
Yeah.
Okay, good.
Ran.
So I got one more question, Adam, on this whole topic. So you hear a lot of people talk about, 21st century brain melt, dopamine addiction. Dr. Ned Hallowell at Harvard has that idea of attention deficit trait. What is happening neurobiologically over time with chronic exposure to massive excessive distraction?
Yeah, it's a really great question. I'm still hearing myself a little bit. I'll try to not scream like I'm doing now. Is that okay? Does it sound reasonable now? Okay.
Totally does.
We know a lot about the impact of distraction, interference, multitasking like crazy on acute performance, right? It's very empirically accessible. You can do a study where you have someone focusing and then you throw something at them to interrupt them. And so most of the data that you read, everything that I was just talking to you about was based upon acute interference. I was just, since it just happened, that echoing is like a perfect example. Like just suppressing that bottom up information was really exhausting for me and really hard to maintain high level thinking. And so that would be like a perfect study to do that with and without echo. And so it's just what we know the most about. What we know the least about is the long-term chronic effects of engaging in a certain environment, just because it's very hard to study. It's very hard to control. There are so many factors that are present and variables that lead to a lack of interpretation. If you look at the data on the relationship between how people multitask in their daily lives and what their cognitive abilities are when you test them in the laboratory, what you find is that people that are heavy media multitaskers, and we've done a little bit of this work, most of this work is done by other groups, what you find is that they're actually not very good at multitasking. If you look at them in the lab, they're worse than the people that are multitasking less. And not just multitasking, their attentional, speed of attentional deployment, resistance of distraction. And so that's an interesting piece of data, but it's correlational. Right? We don't know for sure that because they multitask all the time with their media, that somehow it has suppressed their ability, their cognitive control skills. It's possible, but it doesn't mean that. An alternative interpretation is that people that engage in their media consumption in that manner don't have good cognitive control skills to start with, and that's why they behave that way. So that's like always the challenge of correlational data. And so we're still missing, we actually have work that we're doing now in collaboration with a group at Stanford to try to get a little bit more causal data about how your interaction with the world around you, especially media, impacts you in the long term. And is that causal?
That makes total sense. All of your work on distraction is just phenomenal, and just want to mention your book as well. Do you mind quickly telling people about your book, and then I got a question for you about tech to switch gears a little bit.
Yeah. So the book is called The Distracted Mind: Ancient Brains in a High Tech World. I'm getting a little interference again. Could you guys both mute? Maybe that seemed to. Okay. Yeah. Yeah, that's so somehow something about that. Yeah, so the distracted mind, ancient brains in a high-tech world, and really it's an evolutionary perspective on how our brains evolved to give us all these amazing strengths, especially goal-directed attention, and how technology has challenged us in a very fundamental way. And it's mostly a science book that I wrote with a colleague, Larry Rosen, who's done a lot of the field psychology. So I talk about a lot of the neuroscience. He talks a lot of the real-world stuff, what happens when children use social media and how it impacts their attention and things of that nature. And then we give some practical tips at the end. So it's a couple years out, but I think it's still highly relevant, especially today. It's an area that I don't engage in research right now. I've sort of flipped everything around almost a decade ago, of instead of talking about the problem of distraction and interference and technology, trying to use technology to create tools to help improve cognition.
Yeah, that's where I'd love to go, because you do an amazing job of balancing both sides of technology. So what are the technologies currently that you're interested in working on? Where's the edge of the research? What are you most excited about with respect to the intersection of neuroscience and technology?
Talk about NeuroRacer, Adam.
Sure. Okay, so let's start with NeuroRacer. So a decade ago, I was basically doing research that you just heard. Everything, we just covered all that: distraction, interference, multitasking, aging, all those aspects. And I got frustrated to think that I was going to spend the rest of my life just reporting the bad news, that we're very susceptible to interference, that our brains get worse as we get older. And I wanted to flip it around. I thought that technology has a lot of promise in helping how we function. And so I had this idea, which seemed maybe a little crazy at the time, and maybe to some it still does, but we've come a long way. So this is 12 years ago now, 2008. I came up with the idea of building an interactive experience as a cognitive enhancement tool, specifically delivered as a video game. Specifically delivered as a closed loop video game. So I'll just talk a little bit about the closed loop and its role in technology implementations to improve cognition. So a closed loop is one in which, first of all, it's a larger term than I'm using here, right? You have closed loop systems in your home right now. Your thermostat is detecting the ambient temperature in your home, and then adjusting in real time a heating or cooling system to maintain an equilibrium. So a closed loop system takes in data and then uses that data in some actionable way and puts it out. So it's like a feedback system. We have very little of these in for human biology, actually. And so the idea of a closed loop video game is one where a participant is being presented an experience through digital technology, right? Which is what we do all day long when we do anything, playing a video game being one example. But instead of a game that just keeps challenging you or rewarding you in some way that's preset, a closed loop video game is recording data about your ability to engage in it. And I'll dive into that because that's some of the fun stuff we're working on now. And then it's adjusting the elements of the experience that you're receiving, the stimuli, the challenge, and the reward, such that it creates a personalized, targeted experience. And my hypothesis was that these type of closed loop experiences can really allow us to optimize the function of the brain. First of all, because the experience itself can be constructed in such a way to activate brain networks in a selective way. As a matter of fact, I would go so far as to say the only way we've ever selectively activated brain networks is through experience. We've never had a drug or neurostimulated to activate, full complex brain networks in that manner. But that's how the brain works. You engage in an experience and your brain responds selectively. So that's the first thing, is that the nature of the experience has selectivity in terms of its network activation. The next thing is that the closed loop aspect of it is constantly putting pressure on it. So what we can do with your data, let's say your performance data, is to create a challenge and a reward system that pushes you right to the level of your ability, but not so far that you're just completely frustrated and stop, or not so easy that you just give up. And what that allows us to do is to take that network that's now selectively activated and apply continuous pressure to it over time. Your brain's own inherent plasticity will act to improve function by any network that's engaged in such a manner. And so that's like a little bit of the idea behind NeuroRacer. Now, all of the technology that we've created at Neuroscape, which is our research center at UCSF. And so just to wrap up this part of the story, what we've been doing over the last decade is first building technologies that use closed loop systems to apply pressure to different networks and improve cognitive function. So we both create our technology in-house, and then we do deep dive research studies to validate how it works, and both also to couple that with neural and physiological recordings so that we can understand the mechanisms of action. So the NeuroRacer, which was our first game from 2008, and then eventually became a research paper published in Nature in 2013, really described our ability to use a closed loop video game to improve attention abilities in older adults outside of the gameplay. And this had two different control groups. We looked at sustainability of some of these effects months later. And by recording EEG activity during gameplay before and after, we understood the neural mechanisms of this change. And so that's like the framework of everything we do, both at Neuroscape and several companies that I started as well, to use closed loop systems in technology to drive cognitive enhancement.
Amazing. I love it. And it maps so tightly, obviously, to flow and what produces flow. So just to make sure I'm tracking correctly, when you say closed loop systems, the fundamental elements of that are in flow language feedback, so immediate feedback, and then the challenge skills balance, and then the constant kind of modulation of that to keep the perfect level of stimulation. Is that right?
Exactly. And that can occur. It can occur with very simple metrics about you, like your performance. So just speed and accuracy would be one level. But it could happen on a much deeper level. So we can, I think we're echoing again. Sorry.
It's me. It's definitely me.
Sorry. But what we're exploring now, so all of our first games that we created were really, our first foray into the space was just using performance metrics. So just speed, accuracy, other type of psychophysics metrics that we could gather with just simple sensors on devices. Now we have a program that we're really excited about. And I talked to Stephen a little bit about this. It's called our multimodal biosensing program. And our goal here is to capture, jokingly, internally, we call it the full metal jacket. Basically, any signals that we could capture about an individual, especially the dynamic ones in the moment, we are looking to do that, and then to as rapidly as possible process that information. So this involves a lot of activities on sensor technology, signal processing, machine learning, to make an interpretable sort of composite of those signals that then we can use essentially as close to real time as possible to update the environment. So this is where we're heading, is how do we advance both the input side through multimodal biosensing, essentially real-time state recording, and then how do we present that experience back to you in a richer way. And for that, we have a lot of work going on in full sensory immersion. So taking VR to the next level. Hear, see, smell, feel, all of that updated based upon that data. That's the next generation of the closed loop. That's what I spend a lot of my time working on and thinking about how to accomplish.
Yeah, the power of that with VR is just wild. Just got a really quick question. Can you tell us a little bit about the background behind closed loop and why it's called a closed loop system? I'm just curious about that. And then I've got another question for you on this.
Yeah, it's an engineering term, and it's used in many, many different fields. And basically, as opposed to an open loop where you do something, there's no feedback of any information about how you do, and you just keep applying again. Many things in the real world are open loop, right? You don't have that tight cycle between what you do and then what comes back to you. I mean, sometimes you do in quite a nice way, but a lot of times it could be very long. Like, for example, our education process is fairly open loop in my mind, right? So a student consumes information, and then they consume, months pass, then they spit that information out as best they can in a test, and then that information is in no way used, I mean, the data that you get from that is no way used to update what they learned, right? So there's a disconnect. It's an open loop. It's like an open, circuit. And so the closed loop just the ideal closed loop is real time, constantly cycling over and over again. So, that's why it's the loop. So information flows in and then the environment flows out.
Yeah, that makes perfect sense. And that's what I was wondering, if it kind of denotes the feedback element.
It does. It does.
Adam,
Go ahead.
Jump in with I just want to build on that with a quick question. So when you look at the literature surrounding the challenge, skills, balance, and flow, there has been a 20-year debate on what do we mean exactly by challenge? What do we mean exactly by skills? For example, among elite athletes, there's studies that show 80%, because talent tends to sort of standardize as you move up. 80% of what we mean by challenge and skills at the elite level can come down to confidence. When you look at things like that, when you look at questions around challenge and skills in terms of how you're optimizing it, how do you think about it?
This is, we have this whole set of challenges as we move forward in our process of understanding what are the elements that we could create the most effective cognitive enhancement technologies. That's something that drives all of my thinking. And when I say cognitive enhancement technologies, I mean that it can be applied to people that are healthy, people that are already high performance that are looking for 1% more, or people that are impaired and have pathology and would fall into neurological and psychiatric diagnoses. So we look across the entire gamut. And we spent pretty much the last decade on trying to understand how we implement the closed loop system, how we're more sophisticated about the algorithms we use, how we could collect richer, more comprehensive data that capture a person's state, how we present that information in more immersive ways, more real world ways. And that's what we've worked on. Now, one of the many things that I've sort of plotted for our next decade challenge is all of these other factors that then go into making this type of technology useful or not. So some of it is, what are the we could talk about the field of psychedelics if you're interested, and we're actually entering that phase soon of integrating it with our technologies. I don't want to create a distraction here, but the reason I bring it up is because if you look at the psychedelic research field, this concept of set and setting is like baked into every discussion that happens, right? What are the things that occur before the treatment, during the treatment, and then after? So the priming, the intention setting, and then on the other side, the processing and integration. We haven't done that part of this equation when it comes to technology-based interventions. It's something I'm really interested in. So from confidence to motivation to establishing safety, goals, an appropriate mindset to be able to learn and to expand. And then how do you really integrate it afterwards into your life, which is complicated and has all the factors that might have prevented you from doing well in the first place. So it's a great question. To me, you could feel like the weight of it because there are so many variables there, but it is our next frontier.
One of the things that I find really interesting about it, and it shows, you see this, so if you go into really early high performance literature, Nietzsche, William James, even Freud, they all.
Hello?
I think we lost it.
Also usually impacted by culture. Did you lose me?
Yes, we heard up to William James. Sorry.
Wow. The technology is extra strange tonight. Early, a lot of the early pre-performance thinkers thought that you had to get past culture. That culture, what we mean by challenge, what we mean by skills is also culture. Csikszentmihalyi talked about this, the impact of culture on what we mean by challenge and skills. That sort of like stretches this topic, out to like colossal levels. Do you even think about problems that way?
I do. The reason I do is, it depends what we mean by culture, but culture is a pretty big topic. But I've, because I travel around the world, I used to travel around the world. Now I stay at home. But when I used to travel around the world, it made me think about things in a really global manner. It was impossible to avoid. I'd give lectures, sometimes 5 continents in a year, and I got to see so many different perspectives on this same topic. And I realized that we know very little about that culture, people coming from different places in the world and the cultures they bring in, besides obviously all the numerous cultures even within a single country. We know that they're pretty diverse. I'm really interested in it. It's actually one of the reasons that we started a program at Neuroscape that the world will learn about very soon. I think I could tease it here because we've been working on it for a while. We call it the Remote Trials Program. And the idea is to be able to do large scale, larger than anyone ever has before, of like mobile randomized control trials where my dream is to be able to do studies of 1 million people, right? In the way that we can answer questions as complex as the one that you're asking, of how do all these different influences that you can only answer with very large numbers, how do they change how the exact same treatment or intervention is delivered and received.
Once you make that announcement, Adam, if you want to do some flow work on that, there's a million questions we'd love to work with you on at that scale.
Yeah, let's definitely return to that. I mean, let's be like totally frank here. Our labs are closed right now. I know everyone's suffering in their own ways. So because of that, and I refuse to speculate on when they're opening, right? I mean, it's such an uncertain time. We feel required to continue our research program, right? And so what we're excited about, until we're back into like MRIs and blood work and physiology recording, which we do at UCSF, we're putting all of our focus on trying to get these remote trials so that we can capture data from people in their homes, really important data like the anxiety and stress and how their sleep is faring and their mood, and children and adults, and then be able to put these interventions that have a very, low safety, risk, like our meditation game and other things, and be able to keep doing our work. So we're putting a lot of emphasis on that, and I will definitely let you know when we unveil that. It'll be soon.
Let me ask you a quick other question. I heard you say this once, that the average adult at work focuses on 11-minute chunks, but is interrupted on average 3 times over those 11 minutes. So we know from flow research on coders that if you're in flow and you get knocked out, it can take 15 minutes to get back in. When you're focused, right, in those 11 minutes, you're getting kicked out for 3 minutes. What's the adjustment cost to get back in? Forget your flow, just to like, how much time are you actually wasting trying? Out of that 11 minutes, right, you're getting interrupted 3 times. How much? What does it cost, just in terms of the switching costs, in terms of time?
Well, there's not a ton of data on that. A lot of that original data was observational data on workers, just watching how people behave at work.
Okay.
That's like real world data of just observation of how people engage, information technology workers, I think were in that study, how they engage in their workplace. We know that you can re-engage networks in your brain, in hundreds of milliseconds. It's a very fast process, but it doesn't mean that you're doing it effectively. And so it's very possible that if you're being pulled out of your focus every 3 minutes, that you're never really hitting your flow and really engaging.
That's where I was going. Yeah, that's exactly where I was going with this. Yeah, that's exactly, because when you said that, I'd heard that a long time ago, and you said it, but when I was prepping for this, I watched part of one of the lecture you said that in, or one of the lectures you said, and it stuck with me again. And I was like, Jesus, that's an insane bit of data. And I don't know if you could ever get into flow if that is your situation. And it also made me wonder, not that now with people at home, I've worked in an office. Put me in an office, I can't function. I've always worked at home, so this is ideal for me. But for people who are not used to it, right, it's the exact opposite. And I'm wondering if even like 11 minutes worth of focus is, that's just out the window. And it's an astounding cost.
I think it is way, way worse. Because I'll have a lot of people reach out to me because they, have read my book, or they know my work, and they're just, it's, I mean, that's why I started this talk by saying we're like in the third crisis is the mental health, using that globally. Distraction is a massive influence right now. Couple that with stress, couple that with being out of your routines. It's gonna be an incredible burden, even for someone that is resilient. But for someone that's already struggling going into this, especially children that might not have the skills to be able to cope with this much, uncertainty and change, it's going to be really, really debilitating to a lot of people. So I think that's true. That's all part of what makes me motivated to get our stuff out there more rapidly.
Mm-hmm. I want to be mindful of your time. Rian, you've been monitoring people's questions. Well, I know Adam has to split fairly soon. Are there questions in the comments that we haven't gotten close to that you want to throw out?
Yeah, there's so many that I think we should hold them, and then we can dive into them. Stephen, I'm thinking with the coaches, but and with you in particular, I would love to ask you a question we often ask folks at the end, which is, if at the click of a finger you could have any research immediately done, and then in your case, let's add to this question, if at the click of a finger you could have any technology built with zero constraints, what would the research be? What would the piece of tech be? And I mean, obviously you've alluded to it already, but
it's the science genie question.
Yeah,
I love that.
That's what we'll start calling it.
It's so satisfying for me even to think about it, because I can almost imagine that's true, and it feels so satisfying to just be like, hello. I would say that's actually easy for me to answer, because I've become sort of obsessed with this idea over the last couple of years. We'll be using it for all of our closed loop video games. We'll be using it in our psychedelic research program. And that is really meaningful, interpretable, real-time state recordings. We want to know where someone is in the moment with just, milliseconds delay. I'll take a couple hundred milliseconds there, and really being able to understand. Obviously, we're not going to have the content, but to be able to know their stress level, to know whether their valence is positive or negative, their arousal, whether their attention is internal or external, are they in flow, all of these things. If we had that accessible to us right now, there is just so much we can do with it to create better tools to help people. So I would take that.
Love that. Be a massive force multiplier, obviously, from there on out. So that's great. Adam, where can people find you? Where can they learn more, read more, support?
Yeah, so I have a bunch of different access points. Neuroscape. If you search Neuroscape, you'll find our website, neuroscape.ucsf.edu. That's like our research center. Achille Interactive is our company. We didn't even talk about this. We have one of our first treatments is out there for the treatment of ADHD just a week and a half ago. I have a website, Gazzaley.com, that aggregates everything. We're redoing it and working on that right now, but that'll be the place that'll have access to all the different things I'm involved in.
Amazing. Well, thanks a million, Adam.
Adam, how long till the Friday night gatherings get restarted? I forget about the lab. What about the Friday night parties?
It's a good point. We're looking for a virtual platform for that, and we're sampling them. There's a couple things out there, so yes, it's coming back.
Ooh. Oh, good. All right, let me know.
We'll let you know for sure.
All right, Adam, thank you so much. It's been amazing, and we're psyched to be back on the podcast again, 100%.
My pleasure.
Yeah, Adam, thank you
Great
so much.
questions.
Great to see you, brother.
I hope your listeners enjoyed, and looking forward to engaging again. I'll talk to you later.
All right, sir. Thanks a million. Bye. And folks, Stephen and I are going to stay on. We're gonna pull on some of the Flow Research Collective coaches, and then dive into more of your questions, because we're yet to dig into them in detail. Stephen, I've got one for you just while I'm pulling Brent on here, hopefully, if he's available, which is from Jason Bissell. He says, is there a relationship between language and attention? Do people with symbol-based languages like Chinese and Japanese create different attentional skills and ways to store information?
Jason, it's a great question. I have no idea. So let me start with I have not a fucking clue. I don't know. But what it makes me think of is that there are visual processors, there are auditory processors, there are kinesthetic processors, and what I wonder is, even if you're in a pictorial system that demands visual processing, if that's not your processing style, if that's going to have an impact. But I don't know. It's a really good question. I plead ignorance. I'm sorry. I don't think I've ever seen anybody work on that. But again,
yeah, it's
I plead ignorance.
It's a deep one. What's up, Brent?
Brent, do you know?
I couldn't hear the question, and I think I should probably plead ignorance on this one too.
All right.
All right, we got another one here. So, are there brain scans that shows the difference in men's and women's attention or distraction? If there is variance, can you expand on the observation? And Stephen, and that's by Katie Troutman, by the way, guys. But I would just expand on that, Stephen. Maybe you can talk about differences with respect to flow in general for men and women as well, or males and females.
So I'm not comfortable with any of it. First of all, this is we don't know. The work hasn't been done yet. And every time, I don't want to say every time, but as far as I can tell, everything that I'm familiar with, where people draw a line in the sand and say, this is different men to women, that doesn't last very long. It doesn't seem to hold up over time. Usually, which is not to say there aren't differences in the brain. There do tend to be, women can be a little more right brain dominant than left brain dominant, and which means that's much more global spatial thinking or global big picture thinking than detail oriented. But again, and that comes out of some of the creativity work where they were trying to find, are there creative differences between men and women? But hey, Connor, a lot of them have not held up over. It's nice to see you. A lot of them haven't held up over time.
Yeah, and I think the reason why I'm here is to jump on that question, because this has been a research interest of mine for a while. And maybe we have a couple people on this call who have been individuals that I've been talking to about this. And so all things considered, there's a strong male bias throughout the flow research. And so that's, somewhat of a known phenomenon. And so I can tell you about some of the ways that we've been thinking about this issue and trying to solve this issue. And so if the question is specifically, how does attention differ across genders? So one way of thinking about that is there's different amygdala reactivity. That's kind of a known distinction between genders. And so that's one way of thinking about it. But in order to have a really coherent view of how flow might differ based upon gender, we've been having a number of different conversations, just trying to collect data, get a sense for, generally speaking, what are the differences. And then the recommendation that I've been making for how to deal with this in a systematic way is to look at something called the Fisher Temperament Inventory. And so the Fisher Temperament Inventory helps give a sense for whether somebody is a little bit more reactive to dopamine versus testosterone versus estrogen versus, I think there's one other neurochemical or hormone in there. It might be serotonin. But regardless, it allows you to start to answer this question that if somebody has a different dominance in one of these, then their chosen flow activity might be different. And so those processes are going to operate differently. Because I think, everyone on this call is, somewhat guilty of having this idea of flow of, high stakes environment, lots of risk. Connor, that is a style of flow, but it's not necessarily true for everybody. Go ahead, Stephen.
How does what you just said, and the reason how can you separate, we know, right, the activity level of your D2 and your D4 receptors, which, influence how reactive you are to dopamine, which influence your risk profile. How do you separate out dopamine receptor and activity and things along those lines from the gender stuff that you're talking about? Because they're both going to manifest as, somewhere on the bravery to anxiety scale, right? Like it's somewhere in there. It's going to show up behavior-wise and structural. Maybe there's measurement stuff deep in the brain that you could do, but how do you think about that?
I mean, I think about it as a new domain of research, right? That there are no good priors for this that I know of. So the way that I think about it is much more rudimentary, which is first, if you're doing some sort of research in a new domain, you do qualitative interviews first, right? You just have open-ended conversations with people.
Sure.
You get a sense for what the general connections are between things. What are the general themes within how people are expressing flow? And then generally you start to build correlations between that and gender, that and the Fisher temperament inventory, or these other arenas. And then you start to drill down into these questions. If we lead with the dopamine receptor questions first, I think we're going to kind of miss the forest for the trees. And so I'm just trying to do the really basic, easy thing first, and then start to build towards a much more fine-grained understanding of these topics.
Gotcha.
So if I were to try to build off this and add some value, so in my dissertation, I looked a lot into the cultural aspects of flow and what had been found. And I'll preface that by saying that it was introduced that they don't know much. With that being said, what I looked at is the difference between what we might consider traditionally collectivist societies compared to those that are more individualistic cultures. So kind of the Western culture compared to Eastern China, Japan kind of cultures is what they had looked at. And so what they had found is that flow in more of these traditional collectivist cultures where they had more kind of Confucius principles or virtues, that they experienced more flow in social engagement. So maintaining social harmony. So in regards to that challenge scale balance, as opposed to, this is again what the research suggests, and I'm comfortable everyone shutting it down, is that there might be more of an emphasis towards goals that are maintaining social harmony, as opposed to individualistic cultures in the West, where it's about, let me push the limit, let me show what I can assert in the world and be different. And so not as focused on social harmony. So I'm curious if that maybe ties in neurobiologically in some way, or just, our thoughts on that.
Yeah, 100%. Yeah, I 100% agree. And so if flow is a game of attention, like the best priors to use are within the attention research. And so to your point, individuals from collectivist societies, if you show them an image of a crowd and it's somebody giving a speech before the crowd, their eye patterns, their vision patterns are different from somebody from an individualistic society. And so they're looking more at the crowd than somebody who's from an individualistic society where they focus more on the main speaker. And so we know that attentional networks are different based upon culture, and it comes down to some of, like, you can see these in some really fundamental ways. And so I think focus on social interactions is one way of understanding flow. Flow in, high stakes, really goal-oriented environments is another one. Flow in, more deep dive creative tasks is another one. And then flow in different embodied tasks it is a fourth one. And so I think we're going to see different clusters based upon things like culture and gender and other variables as well. But it's true that right now our main model is, your high stakes goal oriented phenomena. And that's not necessarily how all people are using flow. And so this is something, this is one of a big aspect of my research agenda, is opening up the field of flow. So it's a little bit less goal, and a little bit more of, these are different types of flow based upon, different personality traits, different dominant neurochemistry, different whatever else.
And this is also, by the way, that's a big split between the European and the American flow contingent. A lot of the European flow researchers are very, there's questions about goal-directed flow versus non-goal-directed flow. And this has been kind of an ongoing argument for like 15 years. And a lot of it comes out of the play research, because play is very, very, very flowy. But a lot of the researchers, the European argument, have said that play is not goal-oriented, which is maybe true at a cognitive level. It is definitely not true at a purpose of play in an evolutionary sense. Like play serves a number of functions. Those are never going to go away. It's always going to be goal-oriented from an evolutionary perspective, but you can, you know, in the way that Adam was just talking about top-down versus bottom-up, you can make a top-down goal-oriented versus non-goal-oriented flow argument, which Connor is poking at there too.
Well, to build off the initial.
Rian, by the way, as it gets darker, it looks more and more like you're in prison. Like I keep, right? I keep explaining.
I got about whether I was.
We're coming for you, Rian. We'll bail you out, Rian.
Seriously.
I'm almost in the bathroom. Just
to play on the initial question about gender difference in flow. If we were, and again, I want to acknowledge that we're 4 white dudes talking about culture and we're talking about male and female differences. So I'm going to plead my privilege and ignorance here. And so I'm going to this a little bit with trepidation. But with that being said, the largest psychological difference that the research has shown between men and women tends to be and obviously there's outliers and there's more crossover than not. With that being said, women tend to be more oriented towards people and men tend to be more oriented towards things. So I'm wondering if when we kind of have that in our mind, if we can relate that to the research we were talking about prior about social cultures that are more collectivist compared to cultures that might be more individualistic. And again, there's crossover more than not, and there's outliers both ways. But I'm wondering if that might lead us into a discussion to explore.
I couldn't focus on the question. Your diplomas, the things behind you were distracting me from the person that you're right. I'm sorry.
Damn that bottom-up system.
Yeah.
Mandatory background for FRC coaches. Got to have all the PhDs on the wall.
That's a good
do you guys
point.
Want to dive into that?
Yeah. Brent, you make a really interesting point, though. Joking aside.
Yeah, but if anybody's interested in this topic and wants to help with the qualitative research, reach out to me because I've been working with a number of different people through this issue. And so if anybody's really interested and motivated for this issue, please reach out to me. And it can be a good opportunity to start to do some really basic data collection. And so where we are now with this process is we're starting to put together different qualitative interviews. We're having conversations about the best interview questions to be having. But this is going to lead the way that we understand these different modalities of flow moving forward.
Okay, guys, I got a couple of interesting questions here. Can you talk a little bit about recovery from concussion and flow? How does a concussion impact getting into flow? And we've had people reach out to us about doing research on flow and traumatic brain injuries. So it's definitely a topic of interest, but I don't know where the research sits on it right now.
That's exactly where the research sits right now. we just sort of covered it, which is the problem. But one of the things, and I'm speaking from just my experiences with a good friend of mine who went through a really bad concussion accident a couple of years ago, and he had been doing flow stuff with us for a while. And one of the things that he mentioned, and there's nothing in the research that I've seen, but this is just from first-person experience, because cognition was slowed down, right? Because it was harder to think, it was easier to get distracted, all that stuff. The challenge skills balance and how they normally related to it was totally skewed, right? It was, in a sense, it was, you know, if you're really exhausted, Adam was talking about how mental fatigue massively impacts our attention resources, and that massively impacts our relationship to the challenge skills balance. And that was exactly my friend's experience. He could tolerate much smaller challenges. He had to really dial back the challenge skills balance. And I will tell you, my experience with Lyme disease, which had a huge cognitive component, that was one of the things that I absolutely had to do to get better, was dial back my challenge levels and come to terms with that, except the fact that, oh, fuck, I can only like focus for an hour a day. So like what's an appropriate challenge when you have an hour a day of cognitive ability at normal functional level? That was the thing I had to deal with. Lyme disease that showed up again in my friend's experience. I would guess that's going to be a recurring theme. And I'm sure there's a million other things, you know, as we start to do research on this. The thing that I like to point out, and I want to throw it over to Connor, I want to ask this as a question, which is both for traumatic brain, and we believe that peak flow can help overwrite PTSD because it lays down new neural networks very, very quickly. So much neurochemistry, you get fast reactions, you get binding, etc. I wonder if high flow lifestyles, first of all, if a high flow lifestyle is neuroprotective, first of all. Second of all, would a high flow lifestyle help restore cognitive function, rebuild some of those networks after TBI? Open question to you, Connor.
Yeah, I mean, they're good questions. In terms of the neuroprotective question, I'm not sure. I mean, if you're operating at an otherwise, you know, streamlined, healthy way, you could see that a high flow lifestyle, if it's, you know, within the bounds of other healthy activity, then you could see that it can have a positive effect. And so possibly, but that's, you know, completely speculative. And then in terms of the other side of your question, this reminds me of a conversation we're having a while back with Dr. Andy Newberg. And so we're just kind of riffing off this idea of memory. And so when you remember something, it's relatively well known at this point that your memory is not a remembering of the original thing, right? It's remembering the last time you remember, the last time you remember, the last time you remember that original thing. And so each time you fetch something out of memory, you're re-encoding it in a different way. And so we're talking a little bit about some of the insight that comes with flow and whether or not it doesn't operate in somewhat of a similar fashion. Where after you come out of, you know, some sort of flow experience, you're changing your relationship. You're kind of re-encoding your relationship back to some of the core filters you use to understand the world. And so how that relates back to traumatic brain injury, I have no idea. I mean, that's definitely not my realm of expertise, but how it relates back to this idea of growth. I mean, one frame that's helpful to think about growth is, you know, peak state integration, and then you have a higher plateau, and then peak state integration, and then you have a higher plateau. And so when Maslow talks about high plateaus, he's talking about that process of peak state integration, high plateau. And so insofar as flow supports that process, you could see it, you know, helping in that process of, you know, personal, like whether it's improving cognition or whatever else. So it seems like there might be a there, but on the other side, I'm really not sure about the connection between that and traumatic brain injury.
Just to add, maybe slightly separate than traumatic brain injury, but we recognize that we love the things that we can get into flow, and one of those things is exercise. And we know when we engage in additional exercise, we're going to get a release of BDNF, so brain-derived neurotrophic factor, which can stimulate neurogenesis and new neuron growth. So I strongly think that there's a correlation there. And the interesting thing that I really appreciate about our work with the Flow Research Collective is that after a flow state, we talk about the importance of recovery. And so why I like this from a neurobiological perspective is that we recognize that the new neurons that are grown as a result of BDNF, they don't just show up and appear and then they're mature right away and they're going to survive. There's such an importance of placing that new neuron growth in an enriched environment, an environment so those new neurons can reach full maturation. And so I think that there's a really fascinating parallel of adding kind of contemplative activities or reflection or recovery, as we say, at the back end of exercise where you get that BDNF. And so I think, Stephen, there might be something to play with in that regard.
Exactly.
Do you know what is the time window that BDNF is in our brain? Like after, do you know what that is?
I don't.
Because
no.
One of the questions where I'm going with this is, and you and I have discussions about post-flow visualizations, right? Where you're going back And especially if it's an embodied thing, remembering the feeling of being in flow, right, seems to allow us to get back there much more easily. But that can be done, you know, at the end of the day. Like you could go skiing in the morning, have a little bit of a flow state, and do your visualization as you're falling asleep, which is when I often do it. That time horizon is too long, correct?
So these are studies that were done with rats, I'll say right off the bat, and it's a famous kind of rat park kind of study. So those enriched environments, they were in those environments right away. So they were running on the rat wheel, and they're in cages that had a lot of light, touch, all these other factors. So they were in that enriched environment, in that kind of space the whole time. So would that BDNF still be within one's brain? I just don't know that knowledge. I would like to hope so, but I certainly do not know. And yeah, so I can't answer it, to be honest.
Yeah, I mean, my intuition is, if there's an area that you don't understand about cognitive high performance, just default to modeling it off of academic high performance. And so in this case, if you're a full-time athlete, you're normally going through some sort of athletic routine. You're taking a nap in the afternoon. One of the reasons why you take a nap in the afternoon is you get an uptick in growth hormone, and then you wake back up, go around the rest of your day, and then get a good night's sleep at night. And so if you're trying to optimize for something cognitively and you don't know, and like you just don't know the terrain, I would just default to that same structure, because we know that cognitive mechanisms for high performance, generally speaking, map pretty well to athletic mechanisms of high performance.
Yeah, it makes total sense, Connor. I love that. So here's one from Geo, guys. How do goals impact attention, long-term goals in particular? And then just to add a little bit, I know Dr. David Eagleman says that the conscious mind sets goals, or has said that in his book Incognito, and the unconscious mind achieves goals, which is obviously an oversimplification. But
that's why we were talking. That's where I started. I
point.
asked this question to Adam. That was my first question to him, which is, how do goals impact attention? Long-term goals impact attention, right? That was the first question I asked him, and this was the exact reason why. Your follow-up question is the exact reason I asked that question, right? And so we know, right? Where I wonder about it, and where it gets puzzling to me, and what I'll throw out to the group is, we know that short-term goals impact perception. We've all driven down a street when we're hungry, and suddenly you notice restaurants everywhere. Then you didn't see them before, street 30 times, and suddenly you're like, oh my God, look, it's a Thai place, and right, and suddenly they're all there. So and that's short term. My question is, when we have long-term goals, especially goals that, as David says, are handled by the subconscious, is that impacting perception? How does that tweak perception over time, if at all? That was what I was trying to get at when I asked Adam, how does this impact thalamic gating? Because that would be a place where a long-term goal, right, where the thalamus it directs information streams around the brain, and it lets certain things through, and it suppresses a lot of other stuff. So that could be a place where long-term goals impact attention. It could also take place kind of like the paradoxical gray, the pons, the reticular activating system. Glenn Fox, who we've had on a bunch of times, who's on our board, does some work in that area as well. He thinks gratitude may be a filter that takes place in those kind of deeper brain regions too, which is a sort of another way of looking at this question. But huge questions, really cool. And I've been looking at the same question because it's right there with intuition, right? When we have long-term intuitions about things, in the future, the kind of insights that we have in flow, where you get a vision of where you can go in the future, right? How does that vision of the future end up impacting perception over long periods of time as well? Are all really cool, strange questions that I don't think are answered yet at all.
Yeah, super important high performance questions for us to answer in the long term. So this question maybe breaks the rule a tiny bit, Stephen, of have a passion, have a purpose, but keep it to your goddamn self. But I'm going to ask it anyway, which is, what is the future once we have the ability to propagate sustainable flow on a global scale? And it's by Omkar. So let's rephrase a little bit. So what's the future? Let's say we built, biophysical-based flow detector, and you can drop in a flow on demand, and it's accessible to all.
So one, I'm suspicious of the idea that we're ever going to be able to drop in on flow on command, because I don't know if the system was ever is sort of designed. I mean, we might be able to draw. I don't know if we're going to be able to, if having a biophysical-based flow detector, it will steer us in the right direction. You won't make as many wrong turns. But again, I don't necessarily know if I think that's going to be the future. I don't. I still don't. I'm not sure the system works that way. That's a level of kind of like neural intervention that I don't see us at yet. Connor might disagree.
Yeah, I mean, I think, the idea of being able to completely control any part of your subjective experience at any time, that's a little bit outlandish, right? Like, I think that's a little bit over the top. However, like, look at the history of our species, and, year over year, we have much better ability to tighten feedback loops and in some way create realities in our own images. And so we can use these different tools, and our tools, as time goes on, first they become, these game-changing new tools that are developed, and then they get refined over and over and over again over time. And so look at what's happened within meditation, right? And so it used to be that with meditation, we had a couple of these different styles that, come from a number of different lineages. But now we have, a handful of different apps that I can all get on my phone specific to the specific demands that I have, the amount of time I have to dedicate to this, what have you. And so I don't think we'll ever be in a state that we can completely control our subjective experience and have flow on demand. But I think we're going to continue to tighten those loops so that we're more effective.
Yeah, that's exactly. I agree.
Yeah. As to the long-term societal implications of all of this, I'm not sure. But I think the current trend is, we're continuing to be able to create realities in our own images. We're able to continuously, refine our own realities and have more and more influence over it. So I think that trend is going to continue. And so as to what that means long-term for society as a whole or anything else, I mean, that's largely speculation. But I tend to be more optimistic than most.
Makes total sense, guys. Brad, are you still there, by the way? I can't see.
Yeah, I'm here. Can you see me?
He's still here.
Oh, yeah. I can't see your video for some reason.
Can others see my video?
I can see your video and hear you just fine.
I can see your video.
Steven, you can still see those, or what?
We can still see the degrees. Don't worry.
Yeah, degrees are still there.
I got you got books.
Shout out to
same thing.
Shout out to Laura Ann Edwards, who's a friend of mine. She asked a question about NLP. Laura, NLP is not a real thing. Like, linguistical programming was this idea people had in the late 80s about sort of how the brain works with physiological signals. And it was sort of parked there. There were some people in the self-help movement who have adopted a bunch of it, and that's why it's perpetuated. And a lot of people in the like pickup artist movement took some of those things and did other stuff with it. But I don't know any serious scientist who works on NLP who takes it seriously. It seems to be a thing that creeps in from the coaching world and the pickup artist world into the high performance world. But I could be totally wrong here. There could be a whole new batch of NLP research that I haven't seen that raises it from the dead. But I haven't seen it.
Yeah, it's one of those weird ones that is simultaneously incredibly popular while massively lacking, in any research or rigor.
I think with a lot of those ideas, like, yes, you're fundamentally programmable, right? And you can change different aspects of your experience. And so there are huge placebo effects associated with anything that you do. And so I don't know, I always think of like the adage of, you know, a father's going fly fishing with his son, and his son falls into the rapids and is going down the river, and the father yells to him, "Don't let go of the fishing pole." And so years later, the son's like, "Why do you care more about the fishing pole than me? Why did you tell me to do that?" And the father just said, "I didn't want you to freak out. I need something for you to focus on. I don't care about the fishing pole, but this was going to prevent you from freaking out, and it was going to give you a sense of agency. And because you had that subjective sense of agency, you actually had real agency in your life." And so I think for a lot of these tools, there can be a placebo effect, but the real placebo effect is just that, you know, it gave you some pseudoscience that allowed you to think that you have agency, and it turns out you actually do have agency. So it kind of worked, but not because of the reasons why you thought it worked. It just worked because it like somehow messed with your belief system such that you assumed that you had agency in your life.
So wait, I do or I don't have free will? I'm confused.
Just don't let go of the fishing pole, Stephen.
Okay. I'm with you. Why would you want to torture fish? I don't know.
So let me see who it's from actually before I ask it. But I'll let you all think on
We're
it.
screening you in advance, folks.
I'm just looking for the name, but anyway, most interesting or surprising research you've encountered in the last couple of months, and I still have no one to attribute that question to. So sorry for whoever asked it.
Interesting research. Well, the most complicated research has to be that paper that Glenn sent us on fear, right, Connor? Definitely. The frontier of neuroscience is thinking about electrical fields created by functional connectivity and how things turn on and off and how they're stored. So stuff around there, some of the stuff that I've seen that's really crazy. There's a good paper. There's some good papers on functional connectivity and psychedelics that have just come out that are really interesting. Not so much. I'm not particularly interested in the psychedelic aspect of it, but I am interested in how they help us think about flow.
So building off that, Stephen, you know, I read a paper recently, and it was talking about psychedelics, but mostly it was talking about the experience of awe and awe that we can experience even in nature, for instance. And so what the paper was proposing, which I thought was really fascinating, I was really interested in it, is that when we go in nature, because we experience a sense of awe, and we kind of connect to a smaller, more humble self. And as a result, and so it tracked the neurobiology of it, and it said that as a result, we feel a sense of unity, a greater unity with others. When we're in kind of that nature mysticism, we might talk about it, and how as a result of that sense of unity, we have increased well-being metrics, but also pro-social behavior. So we feel compelled to live out maybe more of a purposeful life in line with MTP or massive transformative purpose. So that was an interesting article I read recently.
Who did that work? Do you remember?
Give me a second, I'll pull it up.
Interesting, Brent. You still there, Connor?
Yeah, I'm still here. I'm trying to think of if there's anything that I was reading recently that was really, I don't know, game-changing. I mean, I've actually been pretty interested in testosterone recently, and so I've been reading more of that research, which has been really fascinating. I mean, it was kind of demystifying, like, for instance, the connection between testosterone and aggressivity. And so looking at, this is actually coming from Robert Sapolsky's work, who's done quite a bit of work on testosterone, but looking at issues of aggressivity, because oftentimes you associate testosterone with aggressivity. But the main takeaway was that in the same way that, you know, alcohol doesn't make you get into bar fights, alcohol just makes people who are already prone to get into bar fights get into bar fights. The same can be true of testosterone. And so people who have spikes in testosterone, and they become aggressive as a result, these are already people who are predisposed to that. And so what testosterone is doing is it's attenuating the signal in such a way such that if you're somebody who's already subjective to aggressive behavior, you're going to have a stronger aggressive response to testosterone than someone who doesn't. And so it's attenuating that signal in a way that exposes your pre-existing bias.
You see this in the literature around roid rage. Right, the idea that people get into a roid rage, and they've tried to bring this up in court, and there's been nobody's ever come close to proving that it's a real thing, for the exact reason that you're talking about. Is it accentuates somebody who had roid rage had a rage problem long before there was testosterone involved in the system, and testosterone amps, it's just more energy, and it's going to go in whichever direction you have. So that says, you've been studying testosterone. Greg Burns, as you know, back in his fabulous book Satisfaction, argued that he thought, is that Satisfaction?
I have it right here.
Oh, good. Okay. So he argued that he thought flow was predominantly testosterone and dopamine, especially the front end of a flow state. What do you think, now that you've been really diving under the hood of testosterone? What do you think about the role? I know this is something that we're trying to poke at more in our research also, but where are you on it right now?
My initial response to that is that it all depends on your pre-existing biases. But for I do really want to break apart this idea that flow is just flow, right? There are different modalities of flow. And so certain individuals are going to respond really well to high testosterone, dopamine, high testosterone and dopamine environments. But a lot of people are not going to respond to that. So I think for a lot of people, it's going to knock them out of the challenge skill balance. It's going to put them in a situation, or it's going to give them a certain like neurochemistry bias, right? Like they're going to respond to that situation in a way that it's not going to allow them to drop into flow. And so it really depends on your modality.
Wait a minute, there are people out there who don't like testosterone or dopamine? I don't understand. I'm so confused.
I don't understand.
But if your main way of getting into flow is in social situations, then you're going to be more sensitive to pro-social neurochemistry. And so that's going to be oxytocin, vasopressin, whatever else. So you're going to be more sensitive to that slew of instruments, and that's going to put you at the cusp of your challenge skill balance. Whereas if you're someone who's really sensitive to oxytocin, and you get into flow in social situations and you give them a ton of dopamine and testosterone, I think that's going to bring them out of the what they want.
No, by the way, I'm married to somebody who's totally hardwired like that. My wife is very much can only get into flow through endorphins and oxytocin, and the minute you actually introduce dopamine into the situation or testosterone, she's totally knocked out.
Right. Exactly. Yeah. So that's my initial advice. Remains to be seen. Go ahead.
Preston Campbell says here, guys, it would be interesting to see the correlation between someone who has issues with being sympathetic dominant and elevated testosterone. But just off the back of that comment, could you guys break down the nervous system and what parasympathetic dominant, sympathetic dominant, etc., and then maybe Connor, you could mention enteric, what that actually means, because people use those kinds of terms a lot.
Yeah, I mean, I'm happy to break it down. So the autonomic nervous system is responsible for your response for stress. It's responsible for a number of different things, including some core body functionality. And so the autonomic nervous system is intimately bound up with breathing, heart rate, that sort of thing. And so anytime we talk about heart rate variability, we're talking about a measure of the autonomic nervous system. So the autonomic nervous system has two main branches. It really has three branches, but the third branch doesn't really matter that much for us. So it has two main branches, which is the sympathetic branch. This is the upregulating system. And so you have a nerve that goes right down your spine. And if you activate the sympathetic nervous system, you'll dump a bunch of norepinephrine and other neurochemistry into your system. And so it upregulates your system. It elevates your heart rate. It makes your heart rate really static rather than increasing when you inhale and decreasing when you exhale. So it gives you your normal stress responses. And then your parasympathetic nervous system is the inverse of that. And so your parasympathetic system is your so-called rest and digest system. And so with your parasympathetic nervous system, that's when you're in some state of relaxation. And so those are the two main branches. The third is the so-called enteric branch, and that has to do with digestion. That there's some interesting research on it, but it's a little bit less relevant for what we're talking about. And so if you feel really escalated, if you feel really stressed out, that's normally your sympathetic nervous system in overdrive. And so if you want to get into flow, there are a couple different ways of thinking about this. One is that you want optimal balance between your sympathetic and parasympathetic nervous system. Another view on this is that you want co-escalation of both your sympathetic and parasympathetic nervous systems together. And so this is, it's the quickest way to access your autonomic nervous system is through the breath, right? Because through the breath, we can provide bottom-up feedback that we're basically, in a decent state, right? We're okay. And so in order to upregulate your sympathetic nervous system and downregulate your parasympathetic nervous system, right, to give yourself a stress response, you can breathe in, you can have longer inhales than you do have exhales. And if you want to downregulate your system, you can have the inverse. And so much longer exhales than inhales. And so this is the underlying mechanism for all of the breathing traditions, right? All of the different types of breath work that you see, especially in Buddhist, Hindu, whatever traditions.
Just out of curiosity, are there traditions where they don't recommend breathing?
There are a couple of them, but those people actually, they didn't survive for very long. It was
I was going to ask, is this what
finding.
actually happened to Atlantis? They had like a whole mysticism based on we're not going to breathe, and shit, that's the end.
Yeah, maybe that was the maybe that's why the Smurfs are blue.
I got nothing really funny here to say. You set me up nicely, and I'm sorry.
So let's do one more question. Preston's just adding in here. My point being that aggressiveness attributed to testosterone could be related instead to people who have their sympathetic stuck on, as opposed to the testosterone, and/or they could reinforce each other in some people. And
wait, hold on. Does that happen? Can one system get stuck on?
I mean, if you have PTSD, right? If you have PTSD, you're going to be sympathetic dominant. And so, so you can, I don't know, for like you get conditioned to certain levels of neurochemistry. And if you're like sympathetic dominant all the time, these are people who, generally have PTSD. I think there could be a correlation to testosterone. Testosterone is correlated back to a number of different things, including social rank. And so we're a social species. And so kind of your rank within a social group is correlated back to your testosterone. So much of that research is in primates, and it's dark. It is really dark to read that research because some of the findings are crazy, right? Which is, your level of testosterone can be related to your social rank. And if you are to change social rank, then one way of increasing your testosterone is through aggressivity towards other primates. And so a lot of that research is really like sometimes I just don't like thinking about it. But I totally agree with the point that your aggressivity could be a function of being sympathetic dominant all the time, which is creating impulsiveness and aggressivity. It could be an element of that, but I assume that it's going to be somewhat coupled with testosterone underneath the hood as well.
Well, one of the things also, if you're sympathetic dominant, you're going to have more norepinephrine and possibly more dopamine in the system. And both of those chemicals are designed to make us act quickly, right? Get the car into gear, right? And kind of relieve that in a sense, but drive it forward. So that in itself is another factor.
Exactly.
Interesting. Yeah, I was reading about this new treatment for PTSD, the stellate ganglion block, which is basically anesthesiologists use it as an injection into nerves in the neck for pain, but it shuts down temporarily the sympathetic nervous system, which apparently is extremely helpful for 5 or 6 hours for people who are, have been sympathetic dominant endlessly for a decade, 2 decades or whatever, which is super random but interesting, I thought.
Oh, that's interesting. Yeah, I mean, benzos work in the same way. I think I mentioned this on the last call that I was on.
Yeah.
But with benzos, I mean, they're a muscle relaxant, but they also are a strong de-stressor. And so this is, Klonopin or Xanax or whatever else. It's all part of the same genre in pharmacology. And they're muscle relaxants, but they're also strong anti-anxieties, in part because of this bottom-up system of like your body's like, oh, all my muscles are relaxed. Everything must be safe. I'm going to relax a little bit. So it's another way of interacting with that same system. And if you struggle with chronic anxiety, benzos are incredibly powerful tools for teaching you how to regulate better in a stress-free environment. They're also, I mean, you obviously work for a doctor. They're highly addictive as well, and so you want to.
Wait a minute. Is this a better living through benzos argument? Better living through benzos?
That's our next T-shirt. That's our next Flow Research Collective T-shirt.
Let me provide an additional way to experience the relaxation response, we could say. And one that we can all do right after we jump off this call or when we go to bed tonight. It's a simple practice called progressive muscle relaxation. So it's a really, really profound, simple technique where essentially you scan your body and you'd start, let's say, at your toes, and you take an inhale in and you'd clench the muscles in your feet and your toes, hold it for a few moments, exhale, allow the tension to release in your feet, and then just feel the difference in the sensation from the tension to the relaxation. Then you do your calves, your thighs, your buttocks, all the way through your whole body. You clench your hands, you relax, and you do your face, and then you can just really feel the difference between the tension and the relaxation. So if you want to experience the parasympathetic response, that's another modality. Yeah.
Yeah, it's super helpful, Brent. That it's so simple, but something about the contrast of.
I get repeated foot cramps when it literally every time I try to do it, I tense my with a cramp, which defeats the purpose. Because when I relax, I'm left with a cramp, and I can't literally. I don't know what it is. It's mostly me being. I can't use that word.
Interesting. So let's wrap up, gents. We've been on for 2 hours.
2 hours.
So I want to wrap up with one question for all of you. What habit have you been finding most useful over the past few weeks?
I could say a simple one for me. I've really enjoyed, now that summer here in Vancouver and it's a little warmer, just going out at sunset and just down regulating as the sun sets. I feel that I kind of get into a nice nightly kind of rhythm to wind down. And after being outside, and we're very privileged in Vancouver to go outside, I don't want to come home and look at my phone or look at my TV. So it's a very simple behavioral intervention I've implemented in my life that gets me to bed early, waking up early, and then just having a much better day. So that's been one simple habit that's really helped me.
Nice.
Yeah, for me, it's absolutely exercise. I mean, if I didn't have exercise through this COVID situation, I would be far less sane than I currently am, and I'm already borderline, right? And so exercise, I've just had to maintain my exercise and amp it up as much as possible as well, and that is just helped me stay sane to the best of my ability. And Stephen can attest to how sane I've actually stayed. But it's been
for you. It's been fairly good, right? I mean, there hasn't been a massacre in at least 3-4 weeks. So yeah. And I it's funny because I will say is that I've had to I've massively upped. So I went from hiking to I introduced a weight vest and have been progressively weighting up while I'm hiking. I've actually had to make my exercise much harder in a sense. Maybe it's because I'm getting outside less, I'm not skiing, right? There's stuff going. But I have found, especially as this has progressed, I've really had to crank up the amount of exercise I'm actually doing. And I've also started to notice, I talked a lot about doubling up on kind of the cognitive basics, mindfulness, gratitude, exercise, that level thing. And I've also noticed on days where, normally I'll do one of those 3 things a day. And that's sort of how I talk to people. And at the beginning of this, I said, hey, try 2 or 3. What I've found now is, I don't know if I've spoiled myself or it's a COVID thing, is that now on days where I'm not doing 2 of them, like if I'm not, I notice that if I've got a mindfulness session and a heavy exercise session, the quality of the next day's thinking is so much better. And I can't tell if I've spoiled myself. This is a placebo thing. Is it COVID? Is it whatever? But I've definitely noticed that.
Placebo effect is still in effect.
It's going to be the name of my next punk band, Placebo Effect. You're going to think we're playing loud, but we're really not.
All right, guys. Well, thanks a million to all of you. We got 134 of you still on, so appreciate it. You're all
thanks for hanging out,
impressive
people.
From an attention
Next week
standpoint.
we have our last live. They'll keep doing them once a month, but we're gonna do them next week. Is going to be it's 2 months, and we're gonna wrap this. It's gonna be another employee all skate. So it's everybody from the Flow Research Collective, and please come join us. We'll be doing a lot more of this, and we'll see you next week. Thanks, everybody.
Thanks, guys.
Take care. All the best.